Okay, good day. Okay, so now today we are looking at the new uh, effects like new graph type of graphs. What we have here is that we have got sine k x, and we want to see what the effect of k. So your k affects the period of the graph. So it does affect the period of the graph. And how do you get the new period now? When we are having kx, k can be any number, can be 2, can be half, can be any number. Now, we are saying from there, how do we get the new period now? The new period, we say 360 divided by k. So for sine and cos. Then for tan, we have to say 180 divided by k, because remember tan, the period of tan is 180. For example, here, if we have sine 2x, the period will be 180, 360 divided by 2. If we've got sine half x, the period we have to divide by half. And what are we having? We are having what called answer 720. Now, when k is a whole number, it shrinks the graph. It shrinks the graph. Then when k is a fraction, it does stretch the graph. That's what you need to understand. So as you can see here, if we say tan 3, we are saying it's shrinking it from 180 to 120, here, even here, from 360 to 180. But when it's a fraction, like a 130, 1/2, can we see it actually triples here, the period to 540. And here it doubles the period to 720 when it's a fraction. Now, so when I see, how do you now sketch this type of graph? Remember what you need to master here. We need to master that these intervals, major intervals, 0, 90, 180, 270, and 360. So these are the major intervals that you must always work with when you are sketching the graph. You know very well that the amplitude is not affected here. So what do you do now? You know that at 0, if it is cos, at 0, what are you supposed to get? You're supposed to get 1. At 0, what about at 90? You're supposed to get 0. At 180, we are supposed to get -1. At 270, we're supposed to get 0. At 360, we're supposed to get 1. So if we say cos 360, you get 1. Cos 90, you get. These are a major interval that you must always have. But now, let's see here now our new intervals. Now, how do we now see the new intervals? We are going to say, when we have got 2 here, we are going to divide everything by 2. That's what we have here. So if we say 0 divided by 2, what do we get? 0 divided by 2, we're just going to get 0. Then 90 divided by 2, we're going to get 45. So it means that where it's supposed to be 0, cos now, before it's supposed to be at 90, now it's at 45. So now your graph must touch at 45. Now, what about 180 divided by 2? We get 180 divided by 2, we get what you call 90. So at -1 now should be at 90. Then at 270 is supposed to be what you call divided by 2. What do we get if we say 270? 270 divided by 2, 135. So now we are saying the new interval now is what? 135. Then what about the 360 is now 180. So these are the new intervals that we are having now. So this is what you need to work with. You don't need to stress, because some of you will be wondering, how now should I sketch the graph? But now let's see here at 0, we said we're going to get 1 here. And what else do we have? We've got now 45. And what do we have here? We've got, what is this? We've got 90. Okay, so one of our intervals again here. Then we have got what? 135. Then we have got 180. So can we see what we're having here? Now, if you have to check here, you're going to come here, when drawing your graph, we're sketching it, -1. Then we go to 0. Then we go to 1. So our normal graph, we know that it should be starting here. It comes to 90. It comes -1 at 180, 0 at 270, and 1 at 360. So you must always remember as well, when you're drawing your graph, make sure that your curve is smooth. Your curve is smooth. Don't what call the repeat drawing and everything. You mustn't move. You must move once your pencil. Okay. Now that's what we are saying here. So I hope you guys understand here the concept of getting the intervals, because this way your graph cuts is very important. You need to indicate it when you're drawing, when you're sketching the graph. Okay. Now let's see another graph here. We have got a graph of what sine half x. Now we know that what are we going to do? Our new intervals now. We know that we have got 90. We have got 0. Sorry, we have got 90. Sorry about that. We have got 90. We have got 180. We have got 270. We have got 360. These are the major intervals that you work with always. And we know that at 0, it's what? It's 0. Sine is 0. Then at 90, it's 1. Here, it's 0. Then here, it's -1. And at 360, it's 0. And what are we going to say now? We're going to divide everything by 2. So our new period now, we're going to say now, the period now is going to be equal to 360 divided by 1/2. What do we get? 720. We get 720. That's our new period. Now, for that, we're going to say 90 divided by half is just like 90 times 2. We get 180. So this is where you are going to get, what is it? This is where we are going to have 1. Then 180 times 2, we get 360. Then 240 times 2, we get 540. Then what is it? 360 times 2, we get 720. So now when you're drawing a graph, what we're going to do now, we know that 0 is supposed to be at 0 here. Then at 180, that's your 1. Then at 360, that's your 0. Then at 540 is -1. Then at 720, it's 0. Now, as you can see here, our normal graph should be like this. Should come here at 1, and it comes to 180, comes -1 at 270, and comes here. So can you see what we have done with our graph? We have stretched it. That's what we are saying here. The same goes to the negative side as well. When you go to the negative side, we're just gonna go to 180 as our as our minimum. I can't find my rubber here, but it's fine. Let me see here. We're just gonna have 360. Then we have 540. Then we come back to to 720. That's what you're saying. That's what you're having here. Okay. So this is what you do. Then for tan 3x, what are we going to do? We're going to divide. We are dividing everything by what? What is it? We need to worry about tan. We need to worry about 0. We need to worry about 90. We need to worry about 270. 180. We need to worry about 270. We need to worry about 360. And what do we know about tan? We know that it does have asymptotes, and asymptotes, this 90 is an asymptote. So if we say 90 divided by 3, our new asymptote now will be where? 90 divided by 3, we get 30. So here, we know that here doesn't touch. It touches here, it touches here, it is 0 here. Then here it doesn't touch, then 0 there. That's what we have with tan. So here our new values, our new should I say where it's gonna pass? It's gonna be 0, 30, and what do we have here? We're gonna have what? We're gonna have 180 divided by it's gonna be 60. Then 270 divided by 3 is gonna be 90. Then 360 divided by 3 is gonna be 120. So now your new period now is what? 120. So what do we know now? We know that at 30, and 60. So, and we have got 90 and we have got 120 here. So now our asymptote should be at 30. The same goes on the negative side. It should be negative 30. Sorry, it's not that clear here. Then we have got another one, is at 90, 270 is at 90. My graph is I have to squeeze. I hope it's clear. Then here we are going to draw our graph. We know how it goes with our graph of turn. Then we come down. Then here we are coming again like this. Then we come down like that. That's what we are saying here. But we know that our normal graph should be having what is it? Asymptote at 90 and asymptote at 270. But what have we done? We have bring it we have we have shrinked it because of this sign 3, the 3 that we're using. Okay, let's move on to another type of a graph where we are saying x minus p. Now we need to know the effect of p, and your p now it's affect or shift your graph horizontally. So left, right, left, right, left. So that's what it does. It does shift your graph horizontally. But amplitude is not changed. Period is not changed. So these are the two things that doesn't change. They don't change. They remain the same. Now, again here, we know what we deal with. We deal with 0. We deal with 90. We deal with 180. We deal with 270. We deal with 360. Now, what are we having here? We are saying for our graph now to find the shift here. When you have negative here, the trick behind here, when you have a negative here, you are shifting it to the right. When you have got a positive, you are shifting it to the left, because we need to get a 0. For us to get a 0, we say x minus 60 equal to 0. X is going to be equal to 60. So actually we are shifting our graph 60 degrees to the right. So everything we are shifting it to the right by 60. So here, where we used to get 1, so let's draw our normal graph for cos. We have our normal graph for cos comes here, comes negative, comes there, then it comes there. But now let's see what we're having now. We're going to say now, if we are adding everything 60, so we're going to say plus 60, and here what we get is going to be 60, then 90 plus 60, 150, 150, then 180 plus 60, so 180 plus 60, we get 240, then 270 plus 60, we get 330, then 360 plus 60, we get 420. So this is what we are having now. Now, for this graph here, we are shifting everything. So these are your new intervals. Now we know that here we get 1 at 0. Here we get 0. Here we get -1. We get 0. We get what? 1. That's what we know. So these are your new intervals now. So what do you do now? We know that at 60 here, at 60, that's where we are having what? That's where we are having, that's where your graph is. So here it will pass below 1. It will pass below 1. Then where does it go now? It's maximum here. And from there it goes down to, we have got 150 here. Then we have got 240, 240, yes. Then we have got 330. Then allow me to extend this to 420. Then that's what we're having here. So now what are we going to do? We draw a graph nicely. We are coming down here to what is it? To 150, -1 at 240. We come to 0 at 330, then at 1 at 420. So this is what that's what we mean here. So you just have to know that I'm shifting my graph, how many units, how many degrees, 60 degrees to the right. When there's a negative, if there was a positive here, we're supposed to shift 60 degrees to the left. That's what we mean by that. Now here to come again and do the same thing here when we're going to touch here at what is it? Instead of negative 90 plus 60, negative 90 plus 50, we get negative 30. So it's going to touch at negative 30 here. That's what we're having here. Then it goes on to negative 150. Then it comes to 240. Is it correct? Yeah. Then it comes to, is it correct here? Sorry. So it's negative 30 here. Then it comes to what here? We've got negative 150. Let me see. Negative 180 plus 60. We get 120. Sorry, it's going to be 120 here. Then negative 270 plus 60. We get negative 330. Negative 270 plus 60. We get 210. So negative, it's going to be negative 210. Then here, negative 360. Negative 360 plus 60, we get 300. So here it's going to end at 300. So that's what we are going to have here. It's going to reach maximum at 300 before 360. Okay, that's what we mean by when you're drawing your graph. So you must know that you must have these major intervals where it's cutting and where it's 1 and negative 1. That's what's important when you're drawing the vertical sketching the graph. Okay, now let's see here the last graph that we have here. We are saying sine 30, x plus 30. So we know x minus plus 30 is equals to 0, x is equals to negative 30. So we are shifting how many units? How many? We are going where? We are going to the left. So it's going to be negative 30. So everything you are shifting your graph to the left by 30 degrees. So now it means that where it's supposed to be 0, it's supposed to be now 0 at negative 30. We are shifting the graph to the left. Then if we are shifting it to the left, then here, what are we going to have here? We're going to say negative 90 plus negative 30. We get negative 120, negative 120. Then negative 180, just say 180 plus 30. We get 210. Then 270 plus 30. We get 300. Then 360 plus 30, we get negative 390. Then on this other end, we are going to shift it 90 minus 30, 90 minus 30, we get 60. Then 180 minus 30, we get 150. Then 270 minus 30, we get 240. Then 360 minus 30, we get 330. So this is where our period will end. This is where our period will end. So now when you are sketching the graph now, you know that here is supposed to be 0, a 1 is supposed to be at 60 now. So what are we going to do? We are going to sketch our graph. So we start here. It's going to reach 1 at 9, at 60 instead of 90. Then it comes back to 150. Then it comes down to 240, then goes to 330. Then it's done there. Then this side there comes down to 120. It goes there to 210. It goes to maximum of 1. Sorry, maximum of 1 at 330. Then it comes down to 0 at 390. So everything here, remember what we said? You say we deal with 0, we deal with 90, we deal with 180, we deal with 270, we deal with 360. Then everything minus 30, we get what? we're going to get minus 30. Then and here we know, here we know that we're going to get 0. There we know that we're going to get 1. There we know that we're going to get 0. Then -1. Then you're going to get 0. So what is our new 1 here? Is going to be 60. Then what is our new 150? Then what is our new here? Is going to be 240. Then here is going to be 330. That's what you need to understand, guys. If now they say draw for them, maybe you are given the domain to say from 0 to 360, 0 to 360. Now you know that at 360 it will be still on its way, so you just leave it hanging like this. You understand? That's what it means here. You just leave it hanging like this because it's no longer past. It can't pass 360, but at 360 is not 0. It's supposed to be above 0. That's what you need to understand only. That's what you need to indicate there when you're sketching. So if they say 0 to 360, and you know that I'm ending, my period is ending at 330, you just need to sketch above. So indicating that the graph is still going, and at 360 is not 0. Okay. Then we come again to our, what is it, to the tan x minus 45. Again, we are shifting everything. What are the major intervals for tan? For tan, we know that is 0, and it's what? It's 90, 270, 180, sorry, 270, 360. Now, what is our, this is an asymptote. It doesn't touch here. It doesn't touch here. Then at this point here, it's at 0. Here it's at 0. Here is 0. So now when we say minus 45, x minus 45 is equal to 0, x is equals to 45. So what are we doing? We are shifting by 45 units to the right. 45 units to the right. And here is going to be 45. Sorry, why am I writing 450? I don't know. Now 90 is going to be 90 plus 45. We're going to say 90 plus 45. What do we get? 135. 180 plus 45. We get 225. Then 270 plus 45. We get 315. Then 360 plus 45. We get 405. So it means that when you're sketching now, you are going to have new asymptotes now that you're going to indicate. 135 is now touching at what? We've got 135 here. Let's put 135 here. Now, for negative 90, if we say negative 90 plus 45, we get 45. So it's going to be negative 45. That's our new asymptote here. And at 0 is supposed to be at 45. 45. Then here, what do we have? We're going to know that this 225, 225. We'll put no, it's supposed to be touching here. Then 315, 315 is our asymptote. Doesn't touch there. Okay. Now, how do you indicate this now? When you are sketching, you start your graph nicely here, and you come at what 45 is now touching at what 45. Then what does it do? Then it goes down there. Then for this one here again, it's gonna come down here. Our new 0 is 225. Then you go down. So this is what you just need to master, guys, when you're sketching these graphs. Okay, but I will also attempt questions from past exam papers. Then you will understand better how you are supposed to answer what you call this type of questions. But this one is for you to understand these sketches. When you see a sketch and you see it's touching at 30, you must be able to tell that, oh, this graph was shifted 30, what you call what is it? 30 degrees to the left, because you know that 0, I must get what you call it must touch 0 at 0. It must be here. That's the way it must be. And it's not here, it's now this side. And 1 as well is reaching 1 at what? At 60. So here it's actually 60 and what? And 1. That's what you're actually having here. Okay. So I hope you guys, you understand. See you in the next lecture. Thank you.